We are now on to Unit 7, Exponents. Once you've found this in your Google Classroom, type your name in on the first slide and we'll get started. So this unit is about exponents, also known as powers. When we have a number with a power, little vocabulary, the number with the power or the exponent is called the base. So in this case, a is the base and n is the exponent, or we can call it a power. Today I'll be talking about the product of powers property. That means we are multiplying powers with the same base. So the base is the same. The thing with the exponent is the same. So if this was x squared, you'd want an x cubed, for example, would be two things that have the same base because they're both an x. So how do we do that? Your steps are to first multiply any coefficients. Remember, coefficients are your numbers in the front. So multiply those together and then keep that base that should be the same, and you're going to add the exponents. So for example, I have 4a to the m times 2a to the n. First, I multiply my coefficients. The coefficients here are 4 and 2. Just like normal, 4 times 2 would be an 8. And then I am supposed to add the exponents. First, notice that they are the same base. They're both a's. If this was an a and this was a b, we would not be able to combine them. A to the m times a to the n is a to the m plus n. Again, you add the exponents. Let's try some more examples on paper. So here I have 5 to the 7th times 5 cubed. I don't just want to type this into my calculator. I want to simplify what it is and write it as 5 to a different power. So you can imagine that 5 to the 7th means 5 times 5 times 5 times 5 times 5 times 5 times 5, right? 5 times itself 7 times. And then I've got 5 times itself 3 more times. So altogether, how many times am I multiplying 5s? 10 times. Again, I keep the base the same and I add my exponents, and 7 plus 3 is 10. And we're just going to go ahead and leave it like that. You could, of course, evaluate this on your calculator if they asked you to. Next question, a to the 5th times a squared. Again, same base, so I keep that base that's the same, and I want to add my exponents. If this is 5a's, again, you could think of it as a times a times a times a times a times 2 more a's. Altogether, there are 7 a's. So that's why we just add them. Next question, a little bit more complicated. I've introduced more coefficients. So I am going to multiply all my coefficients together. 4 times 2 is going to be 8. And then times 3 is 24. And then I want to multiply my exponents together. So I notice here that I have x's and y's. Remember that we can only combine if they have the same base. So I see that I have an x cubed and an x to the 5th. So x times 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 x. 3x's multiplied and then 5 more x's multiplied is x to the 8th. There's only one y here. There's a y squared. So there's nothing to combine it with. I will just keep my y in my final answer, which is 24x to the 8th y squared. And the next one, or the last one for this page, same idea. I want to multiply my coefficients together. 2 times 6 is 12. My x's, I have an x cubed and a single x. If I'm going to add my exponents here, I have a 3, but there's no exponent here. Well, what's the exponent if there's none there? Well, just like with coefficients, you can also imagine that any variable without an exponent has an invisible exponent of 1, because this is a single x. It's x times itself just a single time. So x cubed here, x times x times x times 1 more x is x to the 4th. And then my y's is y to the 7th and z's z to the 5th. And while it doesn't technically matter what order you put the variables in, you do usually want to write them in alphabetical order, so that's why we did X, Y, Z. All right, on to the next slide. On to our next rule, power of a power property. That is when we have a power raised to another power. How would we do that? First, you're going to distribute the power to each base. Every base in the parentheses will get that power, and then you're going to keep the base and multiply the exponents. So what does that look like? If I have 4a to the m, all in parentheses to the power of n, so this whole thing is to the nth power, I'm going to distribute that power to every base. That means the 4 and the a. So I will have 4 to the n, and then I have a to the m to the n, so a power to another power. And according to my directions here, I want to multiply those exponents. So it's 4 to the n and a to the mn. So multiply those two numbers. Let's see some examples. So if I have x squared cubed, I want to explain a little bit more what that means. I know if I cube something, I'm multiplying that thing by itself 3 times. So if I have something cubed, I have that thing times itself 3 times. So x squared times another x squared times another x squared. And that means I have x times x times x times x times x times x all together, x to the 6th, which is what I get if I were to multiply those exponents. So that's why I multiply exponents when I have a power to a power, because you basically have 3 groups of 2, and that's what multiplication is. The next one, 3x in parentheses all cubed. So I want to distribute that exponent. So 3 cubed and then x cubed. So 3 cubed, 3 times 3 is 9, times another 3 would be 27 x cubed. Next, you gotta be really careful here because there is a negative and then a to the 5th and then a b, all in parentheses to the 4th. So every single thing is to the 4th power. B, the a, and also this negative. What do I do with this negative? Because it's not really a number, but I know, of course, from many previous units, when there's no number, there's an invisible 1. So all these things get that 4th power. So I'm going to write -1 to the 4th, and I want to write it in parentheses to show that the negative is part of it. A to the 5th to the 4th power, and then b also to the 4th power. So -1 to the 4th. That's a -1 times the second -1 times the third -1 times the fourth -1. So all the 1's getting multiplied are going to be 1, but will I get a +1 or a -1? Well, the first 2, negative times negative is positive, times the third one's back to negative, times the fourth one is back to being a +1. A to the 5th to the 4th, so I have 4 groups of a to the 5th. 5 times 4 is going to be a to the 20th, and then b to the 4th is just b to the 4th. And we don't really need to write that 1, so it's just a to the 20th, b to the 4th. And the last one here, 1/2 y all squared, and then 2y to the all to the 5th. All right, so everything in this set of parentheses is being squared. 1/2 squared, and then y squared, and then over here I have 2 to the 5th, y to the 5th. All right, 1/2 squared, that's the same as 1/2 times 1/2. Multiply across, we would get a 4th, y squared. 2 to the 5th. All right, so we got 2 times 2 is 4, times another 2 is 8, times another 2 is 16, times one more 2 is 32, y to the 5th, and then I can combine these. 32 times a 4th, or 32 divided by 4, would be 8, and then y squared times y to the 5th y times 5 more y's is y to the 7th. And we're done.